Let us now investigate the isotopic or isospin quanta and the flavor quanta and then the color quanta. So isospin for the generic D quark is -1,6 plus -1,6 plus -1,6, which is 3,6, which is -1/2. Now, let's look. The isospin contributed by the boson 0 with the entity prime is 0, but the isospin contribution of the boson 0 with the flavored anti-V Rishon is +5,6 and -2,6, which gives us +3,6, which cancels the -1/2, and therefore it is 0 as indicated by the standard model. And we can see that we have the opposite isospin quanta for the anti-B quark. Now let's look at the decay product, the C quark, and we'll see that we have, again, for the generic D quark, -1,6, -1,6, -1,6, so -1/2. And now for the boson plus that was configured, we have a 1/3, which is 2,6, plus 1,6, which is 3,6, which is +1. So again, the isospin is canceled and becomes 0. There is no isospin, of course, on the particle pair here. Now, if we look at the W plus, the components of the W plus that's emitted, we will see that we have no contribution to isospin on the first particle pair that's bringing this spin, but we do have, just as we have in the C quark, isospin contribution by the boson minus, scalar boson minus, which is -3 and -1/3 or 2/3 or 2/6 and -1/6, which will give us -1/2. But over here, due to the reconfiguration of these colored and prime V Rishons, we end up with a expression again of the same boson 0 here, which has the isospin of +1/2, which cancels out this isospin of -1/2, so we have 0 on the W as expected. And like I said before, the antiparticle will have all the opposite isospin quanta of the B. And so there's the isospin. Now let's take a look at flavor. Now the flavor charge is given, of course, by the T and V flavored prime Rishons. And so we have a anti-V here, which gives us a -1. And that is the indicated flavor for the B quark. And then if we go here, we have this pair which cancels the flavor of each of these cancel. And then we have a flavor on the configured boson plus, which on this flavored V here is +1, which is the appropriate flavor for the C quark. And flavor of -2 is carried away. These two boson zeros, the flavor on them cancels, and we have the flavor here on the boson minus. When it combines with the B to form anti-B to form an anti-C, will give us on the anti-C a flavor charge of -1. And so the flavor charges are consistent with the standard model. So let's look at color. As before, we recognize that the half of the semicircle on the right side will give us the color chart. So we have purple, yellow, and red. And you can see also as we hover that the actual quanta of the color is displayed. And so the purple and the yellow will cancel, leaving us a red generic D quark for the B quark. And we would have here the opposite, and the yellow and the purple, now on oppositely configured, will leave us the green color charge, which will be the appropriate color charge for the NTB. Now, the generic D, with this exchange of NT-T quarks, will leave us the same color that we had before. We have a purple and the yellow, which cancel and leaves us a red color on the generic D. And of course, the bosons will contribute no color charge. And if we look at the composition of the W particle, we will see that we have particle-antiparticle pairs with the color in each pair canceling. And so now we have a consistent preservation of color charge or conservation of color charge in the decay. And so that completes our picture of the B quark decay.